Hello, my name is ch3, and this is the summary of the Chapter 3, Metal Oxide Semiconductor Gas Sensors. And there are four titles: Introduction, Physical Parameters of Sensor Element, Gas Sensor Characteristics, Recent Development of MOS Gas Sensors, and Conclusions. First, introduction. Introduction advances in MOS nanostructures. MOS gas sensors benefit from nanostructures like nanoparticles, nanotubes, and nanorods, which enhance sensor performance. Sensoring mechanism. The sensors detect gases by changes in electrical conductance of the MOS layer when exposed to dark gases. Components. A typical MOS gas sensors includes a sensor layer, insulating substrate, two electrodes, and a heating element. Insulated from the rest. Gas sensitivity. Gas sensitivity arises from electron trapping at absorbed molecules, causing bending in the MOS layer, which affects conductivity. Band bending. Absorbed oxygen traps electrons, creating a depletion layer and upward band bending, reducing the layer's conductivity. And there are three equations. And there are three equations on the left and image on the right. This is the band diagram at N-type metal oxide grain boundaries, and the schematic of oxygen trapping stays in a thin film of metal oxide grains. The third equation is from the first and the second equation. So combine the form two equation, we can get the final equation. And this is the role of the oxygen isotope. This is experimental results of the oxygen species absorbed on SNO2 surface. Title 2. Physical parameters of sensor element. This is physical parameters of sensor element. There are three equations. On the left is something related to the sensor element, and there is a image on the right. The image A is SME image of typical nanocrystalline general layer used in MOS gas sensor. The image B is the top view of a typical MOS sensor, and image C is cross-sectional view of a gas sensor. Title 3. Gas sensor characteristics. This is gas sensor characteristics. The image A is illustration of response time and recovery time of a gas sensor, and the image B indicates the gradient of sensor signal change. And there is a equation on the right. It's about the characteristics the relationship between the characteristics and the time. Title 4, recent development of MOS gas sensors. This is recent development of MOS gas sensors. And this is resistance and responses about that. Sensoring response of 3% of AI depot sensor prepared by precursor 1 for H2 in presence of CH4 and image B CH4 in presence of H2. This is a sensoring and this more detailed diagram. And this is the P-type MOS base gas sensors. And as we can see, with time increasing, the resistance will go down. And this is dynamic response of NIO device to 100 to 300 ppm and to gas at 175. And this is more detailed. So the time from 0 to 100 minutes, and the gas off will increase. This is dynamic response of a 9 thin film for 3 concentrations of H2 and CH4 and at 175. Title 5 conclusions. So types of MOS materials. Gas sensors can be fabricated using both N-type and P-type MOS materials, allowing for different sensory properties. Turning sensor properties. The gas sensor's performance can be turned by adjusting the physical and chemical properties of the MOS layer. Physical properties. Key physical factors include porosity, film thickness, electrode arrangement, and substrate materials, all of which influence sensor performance. Chemical properties. Chemical properties can be modified through catalyst addition, surface treatments, doping, or creating mixed metal oxides. Experimental results. Both N-type and P-type MOS have been demonstrated to enhance gas sensor characteristics like response recovery and response times. Current research. Ongoing research focuses on further optimizing these materials and methods to improve gas sense performance. And that's all. Thank you.